Hi everyone, I'm Priya. I took IB Chemistry Standard Level last year and I'll be walking you through the lesson for significant figures. First of all, I would like to start off saying that AP and IB graders care a lot about significant figures, and especially if you haven't mastered this skill already in Chemistry 1, it's very important that you learn it at the beginning of the year of Chemistry 2, because throughout the year you'll be practicing a lot of word problems, and it's important for you to understand when to use how many significant figures. When you take your AP and IB exams in May, the graders do look for the accuracy of your SIG FIGS, and they do have a leniency of ±1. However, it's better to always just be as accurate as possible. So let's start off by reviewing the rules. So the first rule, non-zero digits and zeros between non-zero digits are significant. So taking a look at our examples, 245. All of the numbers in this value are non-zero digits, so it will have 3 sig figs. The second example, 7.907. The zero is between two non-zero digits, which means the zero will become significant. So the number of significant figures for this value is 4 sig figs. And the last example, 907.08. Both of the zeros are in between two non-zero digits, so this will have a total of 5 sig figs. Rule 2. Zeros to the left of a first non-zero digit in a number are not significant. Basically, when you have a value less than 1, the zeros to the left of the first non-zero digit are not significant. So looking at the first example, 0.005, because this is a number less than 1 and the first non-zero digit isn't until 5, and since there are no more numbers after the number 5, the number of significant figures for this value will only be 1 sig fig. However, looking at the second example, 0.0709, the zeros to the left of the 7 are not significant. However, the 0 in between the 7 and the 9, between two non-zero numbers, becomes significant. So this will have a total of 3 sig fig values. Rule 3. Zeros at the end of a number to the right of the decimal point are significant. So taking a look at the first example, 12.000, the zeros to the right of the decimal point are significant, no matter how many zeros you will have. So this will have a total of 5 significant figures. Taking a look at the second example, the zeros to the left of the number 8 don't count because it's a value less than 1, and also the first non-zero value, a first significant value, is number 8. So the 0 to the right of 8 is significant, and which will make this have 2 sig fig values. The third example, 1.0. This, however, has a decimal point, and there is, even though it's only a 0, the 0 to the right of a decimal point is always significant, so this will have 2 sig fig values. Rule 4. Zeros at the end of a number greater than 1 are not significant unless their significance is indicated by the presence of a decimal point. So comparing the first two examples, 12,000 and 12,000 with a decimal point. The first example, 12,000, doesn't have a decimal point, so the zeros don't act as significant figures. However, in the second example, since there is a decimal point, there will be 4 significant values for that number, so that just make sure that you look at whether it has a decimal point or not. Adding and subtracting. The result should have the same number of decimal places as the number in the calculation with the smallest number of decimal places. What this basically means is, like, when you look at the example given, 26 plus 45.88 plus 0.0953 equals 72. Since 26 has no decimal places, this will be the determining number for the number of significant values in your resulting answer. Since 26 has no decimal places, the resulting value should not have any decimal places. The same applies to when you're subtracting values. Multiplying and dividing. The result of the numbers should always be based on the number given with the least number of significant figures in the original problem. So just as a quick reminder, you should always, no matter what, look back to the original problem to determine the number of significant values to use in your final answer. And another mental note just at the back of your mind is that do not round any of your values, even if you have a big scientific notation number. Do not round that number. In fact, store it into your calculator and keep using that number in order to proceed along with your calculations. However, do not round your answers until the very last step when you plug it in to find your final answer. So taking a look at the examples given here, 7 divided by 0.567 equals 10. Since 7 only has one significant figure, the resulting answer should only have one significant figure, which it does in the number 10. And 864 times 12 equals 1.0 times 10 to the 4th. Since 12 has two significant figures, the resulting answer should only have two significant figures, which it does in the case of 1.0. So these are some values that it's a good idea to just commit to memory. 1 mole equals 6.02 times 10 to the 23rd, molecules, atoms, etc. Moles equals molecules divided by 6.02 times 10 to the 23rd. Moles equals grams divided by molar mass. Moles equals liters divided by 22.4 liters per mole. And STP values are mostly going to be used in the gas laws unit, but just know them anyway. 1 atm pressure, 273 Kelvin, which translates into 0 degrees Celsius. 22.4 liters per mole.